A report in the New York Times says Target's sophisticated computers are able to guess when a woman shopper is pregnant based on 25 items that pregnant women buy. Among them, vitamins, zinc and magnesium supplements, and cocoa butter lotion. Toss in extra large clothing or a rocking chair, and the store decides you are pregnant and starts targeting you with baby coupons. But the New York Times says an irate father asked a Target manager why his teenage daughter was receiving baby coupons in the mail. Turns out his daughter was pregnant and had told no one at all. But she had been shopping at Target for products that an expectant mom typically buys. How about that? The New York Times says Target's goal is to lure expected moms during their second trimester. It wants to get them to start shopping them to make Target their #1 store through their pregnancy and then once they have their baby. Is this legal? Yes, but if you find this just a bit creepy, you might want to spread out your shopping among various stores, or the simple way to stop anything like this, pay by cash so you're anonymous.
Okay, this is one example, okay, where Target, a very famous store, figured out a teen girl was pregnant. And the baby, the father of the girls, very angry and went to the store and talked with the manager. And the manager said that these are the things that they have found from the analytics. All right, so I think this is also happened to us, right? When we register for a loyalty card to a particular supermarkets, right, stores, we sometimes we receive coupons, we receive brochures that relate to the patterns of the items that we've been bought, okay, based on the history of our purchasing, right? So if you don't want to reveal these kind of things as mentioned by the news just now, pay by cash. But nowadays no longer is like all the cashless, all right, cashless society. We are in a cashless society. But this there are good things about this, there are bad things about this, but we take the positive ones that can boost up the economy of our countries. All right, so that is association analysis, in general, where the stores or supermarkets trying to look at the frequently the frequently products that we usually buy, all right? Finding some regularities in the data that we have made, right? So all right, so I try to make use of, I try to, just to do a short search in Amazon.com. This is another example of how the association analysis is being applied. All right, I think you also experience this thing where we go to the Amazon.com and I just type in data mining, okay, at the search space. It will get me this book, but besides that, it also will shows me what are the frequently bought together. So they try to pair, to suggest to me some other books like Data Science for Business, Storytelling with Data, that they think these are the item being popular, being bought by other purchasers if they buy the data mining book. And besides that, they also mentions the products that related to this item. So these are some of the products. So sometimes we don't have the intention to buy the other books, but when we look at the suggestion, yeah, I think I could have some books on this topic is very related to me, right? So in a way, we have been caught to buy another items that we don't plan to. Okay, so there's many ways, okay, they will, suggest to us. So besides that, they say the customer who view this item also view all these items. They look at the keywords of data mining, and the books that contains such keywords will be suggested together with that main keywords that we have entered. Okay, so this is one scenario where association analysis being applied. Okay, so looking at that application, okay, so it's a very important, okay, to look at the frequent patterns. So this is why this topic is very interesting to be discussed. Okay, it relates with the big data, it relates to the the task in data mining, of course. All right, so where we can find some usefulness in the data so that it can assist the decision making process to the managers or the organization, be it personal, be it the companies, and so on. Okay, so this frequent patterns analysis, okay, association analysis is very important because it being applied to many applications. The store layout, for example, the way they arrange the products, okay, whether it should be bundled with products B or C, can be, be done with this kind of information. Recommended engine as well, okay, make use of these um, information, these methods to try to suggest what are the things, okay, that people will look, or they will filter the information that we have entered so that they will give the relevant information to our search query, right? So just now the targeted marketing, for example, that we mentioned just now, is how they targeted a segment of customers, uh, a group of customers that most likely will buy the products if we offer uh, new products in the market, for example. So they can minimize the cost of advertising by targeting a segment of the customer. Well, let's have a look on the definition of association analysis. So with that in mind that we have discussed on applications, the association analysis is basically to find the frequent patterns, associations, correlations, or the causal structures among set of items. Okay, set of items mean when we the objects. Okay, the set of items or set of objects that occurs in our transactional databases. Whether it's a relational databases or non-relational databases, that's another story. But whatever we have in the database, we can be correlated with one another. So the database contains the many variables, okay, that represent a set of features, which in association analysis, these features are known as a set of items, okay, a set of items or item sets. So the keywords here is frequent pattern. Frequent pattern is a pattern that occurs frequently in database. So the pattern here refers to the set of items or sequence from the transaction that we have. So simply says the features or dimensions that occur together or which are correlated, right? So that is a frequent pattern. So sometimes people will call the association analysis as the frequent pattern analysis. Well, market basket analysis. Okay. The history of the association analysis actually comes from the market basket analysis. So MBA is one of the earliest application of association analysis, where we analyze the basket, okay, what people have bought, all right, and from there we can look at some occurrence of the products being purchased, right? So having known the information, the stores can use this information to place the product in the same area, so they know that users will look up at these areas to find certain products, and then they will pair with another product because they think if people buy A, they also buy B, example. All right. So the results or the outcomes of the analysis are usually portrayed as percentages For example, 30% of the people that buy frozen mutton will also buy charcoal. Okay, so 30% people that buy A will also buy another product B. And the rules are written in the form of left-hand side implies the right-hand side. So shortly, the left-hand side implies the right-hand side. So the implies is the notation of arrow. So we can also say the left-hand side as the antecedent and the right-hand side as the consequence. Right, so this is the antecedent, the left-hand side implies the consequence as the right-hand side. If A, then B. If antecedent, then consequence. All right, then this is another illustrations of the MBA where we analyze the market. All right, so with this, we can have many ways to improve the profitability, as I mentioned just now, to improve the layout of the stores, on how we organize the products, the web page catalog, and so forth. All right, so the approach is basically by processing the POS or point of sale that we have collected at the barcode scanners, okay, to find some correlations among the items being bought by the customers. So these are some other examples of the MBA where the stores can make use or exploit this information to further improve their organizations of the products and so forth. Okay. Now let's move on to the technical parts of the association analysis. Okay, I mentioned just now about the item set. Okay, the item set of items. So after this, we will refer the item set. So what is item set? It's a set of one or more items. It's a set of one or more items. If I say K item set, means it has X1 until Xk. An item set that contains K items. Support count of X. Okay, support count of X, or shortly SUP, support, is a frequency or occurrence of an item set of X. So if I want to know what the support count, okay, or count of A, C items set of A and C, right, in this transaction table, all right, we have for this transaction table, TID means transaction ID. We have list of items bought. As you can see here, there are 4 transactions labeled as transaction 10, 20, 30, and 40. So the first transaction of ID or of 10, for example here, the customer bought items A, B, and C. The second transaction, the customer bought A and C and so forth. So if I want to know the support count or the count of A and C in this transaction, means how many times this combination occurs. All right, so it occurs twice, isn't it? So one here, A and C, occurs in transaction 10, and another one, it occurs in transaction 20. So number of times it appears, or in other words, the frequency of occurrence. So it is 2. And the support S, or the support with the notation small s here, is another terms that refers to the fraction of transactions that contain an item set. All right, so the fraction of transactions, meaning we are referring to the whole transaction. What is the percentage or what is the fraction of transactions that contain that particular item set? So we know that the support of A and C just now is 2, all right, 2, 1 and 2, and the whole transaction is 4. So the support for this combination A and C is 0.5, all right? Or in terms of percentage, if convert in percentage, it will be 50%. So 50% of the transactions contains a combination of A and C. So we can also have the single items, all right? We can calculate or get the fraction of a single item A here. For example, as A, we will get how many A's occurs in this transaction? 3 times. This is 1A, another A, another one is A, so 3 over 4. All right, so if we convert into percentage, it is 75%. So 75% of the transaction contains A. Okay, mean people's, this is a very popular product where most of the customers will buy items A. All right, so there is support. Another measures being used for this association analysis is confidence. Okay, confidence with the notation C. It measures how often items in Y appear in transaction that contain X. So X implies Y. So in other words, the Y here is depend on the X. Okay, the probability or the conditional probability of Y depends of X. If people buy X, they also buy Y. So in this case, if I want to assess or analyze the rule of A and C, all right, I want to know the confidence level of these relationships. I want to measure the confidence level or how strong is the relationships between A and C. So I look up the support. So the support values of A and C divide by the support of A. All right, so with this, I will get, if A and C just now, we will get 2 over 4. And for the A, we will get 3 over 4. All right, we transfer it over here, and you will get 2 over 3. So 66.67, we are confident that people that buy A will buy C. Okay, that's how we translate the relationships of the items. Any questions so far? Are you okay? All right. Okay, thank you. So the next one, I want to move to the next slide. Why is so hard to move? All right. Let's continue a little bit of this one. So this is further explanation of what I have explained just now. But the things that I would like to emphasize here, that the association analysis involves 2 steps. Okay, involve 2 steps. First is to find the frequent patterns, and the second one is to generate the rules, what we call as association rules. Find the frequent patterns as the first step. Next is to generate the association rules. Okay, then the one that I mentioned just now, the support, okay, the confidence are called what we call as the measures of interestingness. Okay, the measure of interestingness. Why we say interesting? Because we want to see what are the interesting knowledge or interesting rules that can be used for the business decision, right? So again, just to repeat, because it's very important. So supports refers to the percentage of the baskets where the rule was true, both left and side and products, right? Or in other words, the supports indicates how frequently the if-then relationships appears in the database. It's not how many times it appears in that transaction or in that database. So in terms of the formula, if it involves X and Y, if it involves item X and Y, all right, the supports formula is the total of records with the items, with the item X and Y, divided by the total of transaction. Or shortly, we can write support is equal to frequency of X, Y, X and Y divided by the N. Okay. And the confidence, again, I repeat, it measures the percentage of the baskets that true, okay, for the left hand side also contain to the right. So we want to see how reliable is the rules. That's why we call it a reliability measures. So the confidence try to tell us about the number of times the relationships found to be true. Okay, relationship between X and Y. So it measures how true these relationships between item X and Y. Okay, in other words, in terms of equations, we say the confidence is equal to supports of items divided by the item set in the whole transaction divided by the support of antecedent. Or we can make it like this as well, where the confidence is equal to the frequency or the of the X and Y divided by the frequency of X. So if you notice, we are trying I want to erase this. Sorry. How do I get back? Okay, what I try to tell is the antecedent. So if you want to calculate the confidence, it has to be divided by the antecedent. All right. The antecedent here is the X. Remember, the antecedent implies the consequence. Antecedents imply consequence. So the next one, another measures beside the support and confidence is what we call lift. Now, having known the supports, having known the confidence, we still want to look at on how significant is the rules that we have generated. How significant the truth, the rule that we have generated. So with that concerns, we introduce another measures, or research introduce another measure called leaf, right? So if you look at the leaf, all right, the formula, don't worry about the explanation, you may get confused with that. We basically want to measure the performance of the rules. Just now I mentioned about the significant rules. We may have many rules, but how significant is the rules? So the leaf will let us know this kind of measures, right? And this are the formula. The leaf is equal to support of items of item sets divide by support of antecedents times with the support of conditions. So if you compare between the previous equation to this one, this is basically taken from the confidence. Okay, and then because we want to look at the significance value of the rules that we have, we will divide it with the another measures of the condition. And the condition here, if we are referring to X and Y, we are measuring the support of the Y. All right. Okay, I think this is very interesting. If we can, look at the by example. All right, this is more meaningful. So just now, we said that the finding frequent pattern involves two steps. This is the first step where we want to find frequent patterns. How? By calculating the support value for each items. Then we discard. We calculate the S, and then we discard any irrelevant item set. So you may ask me, or you may wonder how to know the irrelevant item set. So with that, we have what we call as the threshold value, or the mean support value and the mean confidence value. So we need to know what are these value, because we may generate a lot of rules. So to take out the gist of the rules, we need to have some criteria, and with that we will identify the mean support and mean confidence. So let's say these are the transactions that we have. Okay, we have 4 transactions, and each these are the items being bought by the customers. All right. So in order to get the first step, we need to calculate the frequent pattern of each item. So if you look at this, we have how many unique items? We have A, B, C, D, right? E and F. We have A, B, C, D, E, F. So this is with the K equal to 1, means one item set. If we extend the frequent pattern to K equal to 2, we will get a combination of AB, AC, AD, and so on. All right. So with these frequent patterns, we need to know what are the support values. Okay, what are the supports or the count for each of the item. A, for example, is 75%. How do we calculate this? We count the number of times it occurs. So one here, and one here. This is 3/4. So this is 75%. So same goes to the next one of B that occurs twice at the transaction 10 and transaction 40. So this is 2/4, which is 50%. So we do the same to the rest of the frequent patterns that we listed here. Okay, so this answer the first one, calculating the support value. And the second one is to discard or remove any irrelevant items. So these are the threshold that being given to us. So we have the mean support of 50%, meaning to say the one that below than 50% will be removed, which we consider that as an infrequent patterns. So D, E, F, and AB are all below or less than the mean support of 50%. So these are the infrequent patterns and should be discarded. It is irrelevant to be used. Same goes to the AD. So this will be removed. So we just remain with these 4 frequent pattern sets. All right, so that is step number 1. Okay, so now the first step, make use of the support. Now let's have a look on the second step. The second step, try to generate the rules by calculating the confidence value. So we will generate a lot of rules. Okay, this is a very short, simple example. You can't see the real example. You didn't see the whole pictures of rules. But if we involve with the items in the supermarket or whatever real data set is very huge. So we need to specify, we need to extract only the interesting rules. All right. Well, so with this in step 2, we will make use the mean confidence threshold. We have the same threshold here, which is 50%. So how do we calculate the confidence? All right. So remember just now, the confidence is basically the support value or supports of that rows divided by the support of the antecedent. So if let's say we would like to further explore on the combination of A and C. So I have A and C here. All right, I want to explore further the A and C. So I want to explore the rule A and C. So for rule A implies C, okay, the support for this rule A and C is equal to the support, the combinations, okay, how many times it appears. We have calculated this one already, which is 50%, right? And what is the confidence? The confidence is the value of support that we have calculated divided, so this is the one that we have calculated, divided by the support of A. So support of A is basically the antecedent. So this is antecedent, so divide by the support of A. So this brings us to 66.6 or 66.7. We want to make it the same as this one. So when we write it as the support and confidence, so the rules of A and C in bracket 50, 66.7, the first value refers to the support. The second values refer the confidence. Okay, so if we want to translate in terms of the sentence, we will say, okay, there are 50% of transactions that's there are 50% of transactions that involve items A and C, occurrence together, okay, A and C. And there are 66.7% of customer who buy A will also buy C. Okay, the confidence. So I mean, with that combination of rules, we are confident that people that buy A will buy C, and the value is 66.7%. So if we look at this, and how we ask, how about the inverse of the rules? What about C implies A? Will it be the same for the figure of support and confidence? All right, if you can look at this figure, the support is the same, but the confidence is different. Definitely true, right? Because the formula of confidence is divided by the antecedents. So we have to look at the left value, whether it's A, whether it's C, and so forth. And definitely it will give the different answer for the confidence. So what we try to conclude here is that the supports fits what we call as the bidirectional rules, right? Meaning it is true if A implies C or C implies A, but for the confidence, it doesn't fit the bidirectional rules. It's only one direction. It is not true for both directions due to the fact that we have to divide by the antecedents. All right. So that's basically how we generate the rules of make use of the association analysis, make use of the measures of the support and confidence. Okay, I have a short exercise for you all. All right. Assume we have 5 customers here. All right, we have 5 customers, and these are the transactions that involved with these 5 customers. Can you calculate what are the support for the milk, what are the support for the chip, and how about the support of the combination milk and chip? Okay, so in other words here, we are interested to know a combination of milk and chip. All right, so I give you 1 minute for you to simply calculate these measures. All right, I think this is not that difficult. You can do it easily. All right, so please do. I give you maybe 1 to 2 minutes. Okay, class? Is that okay with you all to do this short exercise? So, class, do you get the answer? If you get the answer, can you write down or space your answer at the chat area? You can just snap and share your answer with me and the rest of the class. I would like to see your answer at the chat area. So, Lukman, can you get the answer? Can I get few response from from the computer science student here in UITM? You can paste your answer. Zikri, Hafiz,
Madam.
can you paste your answer if you have finished it?
Okay.
Thank you. Can I get some response from the international student? Edric or Atira, Vailina, Gabriela. That's very nice, beautiful names. Yeah. Okay, please share your answer with us as well. What are your answer for the support of milk, support of sheep, support of milk and sheep? So we would like to investigate further on the rules of milk and sheep. Okay, I can see answer from Lukman here. Okay, thank you, Lukman. Other students, please. Or any rep from the international student? There's one names Ainyoman Manutama. Are you here? Let me check on the list of the students. Or Devin Prawira Arisaputra. Or Edric Veda Adia Ayatma. Okay, if you are with us, please write down your answers at the chat area. I will give another 1 minute for you to share your answer. Okay, I still didn't get the response from the other side, but I hope you are able to calculate it. All right. Okay, the rest of you, did you manage to get the same result with Luqman Hakim?
Yes.
Okay. Okay, you managed to get it. Okay, so Luqman's answer is the same as what I have here as well. All right, so we have the supports of milk 0.6. All right, so the support of chip is 0.4. Support of milk and chip is 0.4. Okay, if we convert to 20%, it will become 60%, 40%, 40%, right? So, mean to say, if you want to translate this, okay, 40% of transactions involve, okay, occurs milk and chip for the support. Now, we have analyzed the items by means of the supports measures. If we want to analyze the relationships, then we have to make use of the confidence. So if we are interested to know, okay, to analyze these relationships of milk and chip, all right, so we further analyze by looking at the confidence and the leaf values. So the support of milk and chip over milk, okay, over the antecedent is whereby we need to get 0.4 divided by 0.7, which is 0.67. Okay, so convert to percentage, you will get 67%. Right, your answer is the same with this one. Okay, very good, Luqman. I think the rest of you also got the same answer. And then when we further analyze these relationships with the leaf measures, we get the 1.67 values. Okay, the value is 1.67. So I would like to share how do we translate the leaf measures, the leaf results. So now if we are able to get the leaf values greater than 1, it shows a very strong relationships. We are highly confident that the rules are very significant. Okay, that people that buy milk will also buy the chip. That shows a very high cross-selling opportunity between these two items, right? So if the value is greater than 1, it shows a very high cross-selling opportunity. But if the value is less than 1, or maybe we get a negative value, it will give the other way around. Meaning to say, that combination is not important at all. So we shouldn't bundle that items together. So it indicates another information to us that that combination is not interesting, all right? It's not significant by looking at the values of the leaf. Okay, so you can further analyze this by doing the other way around of the rules by looking at the how about chip implies milk. What are the confidence value? What are the leaf values for that particular rules of chip implies milk? Okay, so that's basically how we calculate the support, confidence, and leaf, and how we translate into information or knowledge that can be very helpful to the management or to whoever involved with this kind of applications. All right, so now we just finished the first part of the association analysis. I'll continue with the a priori algorithms. I give you a few minutes break before we move on to the next one, all right? Okay, let's take a break. This is a short one, I think should be okay. We are running out of time. 3 minutes break should be sufficient.